Okay, so this question is in regards to type 2 molarity problem. Okay, so for type 2 molarity problems, you treat it as a simple stoichiometry problem, okay, meaning that you're going to use the stoichiometry path, okay, and it uses molarity M as a conversion factor. So you're going to change molarity or molar from for it to say moles of solute over 1 liter. So let's say that they give you 2.6 molar in the problem. Okay, you're going to change it where it's going to say 2.6 moles over 1 liter. So in short, what you're doing, you're bringing the number over and just saying moles over liter. Okay, so here's the problem. The question reads, magnesium metal reacts with 65 milliliters of 1.50 molar zinc nitrate solution to produce the products shown below. Okay, so basically what they're saying is that magnesium and zinc nitrate, both of them are reacting to produce these two products. Okay, assuming the reaction goes to completion, how many grams of magnesium are consumed by the reaction? Okay, so the main question that we're trying to find out the answer for is how many grams of this product that is called magnesium were consumed. Okay, so to be able to do that, I like to box what they're asking me for, and then I like to write it over here. What we're looking for, I'm going to have some type of number that is going to have the units of grams, and then it's going to have the element of magnesium. And that information better appear somewhere in the top of the dimensional analysis. Okay? If not, then that means my answer is wrong. Okay? So basically, you're going to change the given information, the 1.50 molar, to a conversion factor where it's going to read 1.50 moles over 1 liter. So basically what you're doing is just bringing the number over and saying moles over 1 liter. Okay. So the other information that they provided is 65 milliliters for zinc nitrate. Zinc nitrate is this here. Okay. So I'm going to start with 65 milliliters of zinc nitrate. Okay. And now from here, I'm going to take it. So I'm starting here, almost like a star. Okay. And then if I have milliliters here, I'm going to have milliliters here. Now I can follow my stoichiometry path, and I know that I'm basically going to start from milliliters because that was the given. I'm going to go to liters, to moles, and then to moles, and then to grams. And the reason that I know I'm going from milliliters all the way to grams is because of the given information. We're starting with milliliters. We want to end with grams. Yes. Another thing too. The reason I'm not going from milliliters to liters and then from liters to moles and then just going straight up into grams is because we're comparing two different things. And those two different things consist of zinc nitrate and magnesium. Okay, so therefore we have to do the mole to mole ratio. Okay, so we started with milliliters. Now it says in here for us to cross this bridge that for every 1 liter we have 1,000 milliliters. Okay, so we're going to use this as a conversion factor. So we have 1,000 milliliters for every 1 liter of zinc nitrate. Now I can basically cross this off here, okay, because we're done with milliliters. So I'm going to continue. And I know I'm going to continue. Why? Because I'm in liters. I want to find the units of grams of magnesium, and I don't have that here. Okay, so I'm gonna go diagonal, and I'm I'm going to write liters of zinc nitrate. Okay. Okay, so we're basically right here. Okay, we already went from here to here. Now, this is saying that I have to use molarity as a conversion factor. Okay, so whatever number that they gave me, I'm going to change it to a conversion factor. And that's what I did a few minutes ago. So basically, let me pull this up a little bit. Basically, what we're going to do, we're going to use this conversion factor over here. It says 1.50 moles over 1 liter. So 1 liter and then 1.5 moles. Okay. And moles of zinc nitrate, of course. Okay, so I'm done with liters of zinc nitrate, so I can cross that out. Now, whatever I have here, it needs to be shown diagonal as well. As far as the units go, moles of zinc nitrate. Okay, so now from here, we are right here. Okay, we already went from here to here to here. Okay, by using this conversion factor. This conversion factor is for gases only. Okay, so don't pay attention for this one. We don't need it for this particular problem. You can use it in other type of problems, but not for this one specifically. So every time you're going from here to here, you're going to use one of the two. Okay, but right now we're using the bottom one. Okay, now basically what we're going to do, we're going to compare the mole to mole ratio, and it tells you there. It says look at the coefficients in the chemical equation to compare the mole ratios. Okay, so we're going to look at the coefficient at the balanced chemical equation. Okay, we have zinc nitrate. Okay, so I'm going to come over here and I'm going to look how many moles do we have. Technically here in the front, if there's no number, there's a 1 to be understood. And for magnesium, it's the same thing. Okay, so I'm going to put a 1 here. Yes. And now from there, I can cross out moles of zinc nitrate. Okay, because we're done with it. Now, we're comparing the moles of zinc nitrate to the moles of magnesium. Okay. So we went from here to here. Okay. I'm sorry, I'm getting ahead of myself here. Okay. All right, so we are basically right here now. Okay. Now the next part is for us to arrive at grams. How do we arrive in grams? Well, it tells you in here. We're here. We can either go straight or we can go up. But I know I'm looking for grams. So I have to cross this bridge. So we have to find the molar mass. What is the molar mass? The molar mass says that for whatever mass that I have, that is going to equal to 1 mole. Okay? So let me come out of this a little bit, first of all, because else is going to be a big mess. So basically, I'm going to write 1 mole, because that's what the conversion factor told me. And also because it's going diagonal, so you have to have the same units. Okay, you have to have the same units. This one is coming from the conversion factor of saying 1 mole for the amount of mass. Okay, so 1 mole of Mg. Okay, so I'm done with moles. Okay, now we have arrived in our destination, which is basically the grams. Okay, 1 mole for the amount of mass. The amount of mass of the of the element, which is magnesium in this case, which that is going to be 24.31 grams of Mg. And that's just found in the periodic table, okay? So if you look closely, you can see that magnesium atomic mass is 24.31, okay? All right, so we have found what we were looking for. So we can stop there at that point. Notice that my units are matching grams of Mg and grams of Mg, which is basically what I was looking for when we first started that, okay? And that's going to give you an answer, once you round it to 3 sig figs, an answer of 2.37 grams of Mg. Okay, so that is going to be your answer.